We welcome you once again to the final episode of the current series of the MCC Livestream series, where we are talking about Everyone Can Code from Apple. Let's get our introductions done first and foremost. So with me, as always, is Mr. David Kirtland, an Apple professional learning specialist and accredited Apple trainer of teachers up and down the country. And really pleased that David's with us again today. My name is Richard Child. I'm the Education Manager for MCC Digital. We are an Apple Authorized Education Specialist and help schools up and down the land with their Apple deployments. Now, we have been talking about Everyone Can Code, which is a whole block of resources from Apple to support the teaching of computing and coding. We've looked at the teacher resources that are available. We've looked at a couple of the student modules that we've worked through. And we've had a look at Spheros a week or two ago. And we saw how they work with their own app, the Sphero Edu app. And there is tons and tons of content in there. But the added bonus is, and this is where everything's coming together for a big finale, we're going to mix Sphero and Playgrounds together. Stir up the pot and end up with a game of Pong, are we not?
That's right. That's exactly what we're going to try and do anyway.
Perfect. So take it away. Let's hear all about it.
Okay, great. So I've got a Sphero Bolt here, and we are going to look at how we can use that with some of the playgrounds that we get from Sphero. So let's jump straight into Sphero here. And I'm fairly new to these, and I will say, playing with these over the last few days, these are brilliant fun. The children are going to absolutely love working with these in the classroom when they're kind of running around the floor and you're solving all these problems and chasing them about. In terms of hardware, it just makes coding so much more enjoyable. When you're coding something on the iPad and then all of a sudden something moves on the table or a drone takes off or something runs across the floor. I've spent a lot of time with things like Lego and the Ubitech robot, so you've got that whole DT element. But I'm not using these much in the classroom yet, but I can't wait. These are so good fun. We've had a lot of giggles with these last few days. So I've already downloaded the Sphero Arcade 1 playground. These are all free. You just press that See All button where it says More Playgrounds and you can download the Sphero ones there. And there are three. We're just going to have a look at the first one today. But each one of these is about recreating a classic arcade game. So as Richard says, the first one, we're going to have a go at building Pong in real life today. The second one is about Bop It, that game where you kind of move things around and do different maneuvers to it. And then the final one is recreating Pac-Man, which I need to try and have a bit more time with that one because that sounds great. But we're going to do the first one just around Pong. So let's jump straight in. And the first thing you'll notice with these is that they do all follow the same kind of structure of the Apple lessons here. They all have this introduction, and then once we get into it, you will see that they look and feel pretty much the same. So this is just kind of saying this is what the Sphero is. We've already seen a Sphero using the Sphero app when Darren introduced it a couple of weeks ago. But it's just giving us that kind of recap and talking that these do talk over Bluetooth, and it's giving us a little indication of what some of these commands inside Swift look like. And there's a bit of a familiarity already. You'll recognize that kind of structure and some of the camel case and how we work with these. So let's jump in and let's have a go at getting familiar with the Sphero Bolt. So there we are. We want to talk over Bluetooth. So I'm just simply going to tap that Connect Robot button up in the top corner. And it should see mine here, the snappily named SB0984. So if I select it, we should see it light up. There we go. It's lighting up and flashing at us, and we've got a little matrix on the front. So I'll just have a look at what we have here. And this first lesson is really quite straightforward. This is just about getting familiar with controlling that Sphero and just seeing what the basic commands are. Now, it's already in for us. The coding is already there for us on this one, and it's really just to have a little go. And while we've got a robot running around the floor, quite a lot of these lessons down the other side, the right-hand side of the screen, will physically map out what the movement of the robot. This one's telling us, look, that it's measuring. It's got the velocity there. It measures the distance of how far this Sphero travels. So we've got our commands. We've got a roll command there. But we've got something slightly different already. So one of the things you will realize is once you start working with this, I would suggest you have worked through the entirety of Learn to Code 1 with the children first. So there is that understanding of the coding and the structure. It does bring in a lot of those key kind of techniques, things like the functions and the loops early on, but we're already putting things in here like variables that later on in Learn to Code 1 we do cover, but we haven't covered them quite yet in this series. But we've got some variables in here. inside those parentheses. So we've got a roll command, and we've got two variables. We've got a heading variable and a speed. And at the moment, these don't mean a lot. We've got a heading of 0, and we've got a speed of 50. And then our next command is wait for 3, which is 3 seconds. And then we've got a stop roll. So knowing what we know from Sphero already when we looked at it in the app, we don't measure distance. We measure the time that it takes to travel. And of course, that changes depending on how fast the Sphero is moving. So this is really just for the children to have a go now. We can just press run my code, and the Sphero will run across the room. Let me just place it on the ground for the moment. And I will show you this in a moment. It's going to involve me jumping up a little bit and showing you some of this. But if I just run my code, my Sphero is now kind of shooting across the floor, and it's telling me there on the screen I've gone 27 centimeters. What we can do with this is think about, well, if we want to travel further, what do we need to change? Well, we've got two variables we could change here. We've got the speed, which is set to 50, which is kind of half speed at the moment. We could set that up to 100. So obviously, if it's traveling faster, it will travel further. But we've got that wait command as well there, and that's the duration. That's how long it's going to roll for. So at the moment, it's rolling for 3 seconds. If I double that to 6 seconds, obviously, it will travel twice as far. That last command, stop roll, well, we could get away without having that, because if we stop spinning, the Sphero will come to a stop. But because it's a ball, it has some momentum. You'll find this when you program in anything that has motors of any sort. It's the same with the UVTech with the MeBot. It's the same with some of the Lego robots as well, that once the motor stops, they will continue the travel for a moment or two. So stop roll just puts the brakes on. It just makes it stop much quicker. So it is worth having that stop roll command in there. So this page really is for the children just to get a little bit more familiar, experiment with the speed, experiment with the time, just get a feel for how far it will travel. And of course that will vary depending on the surface. I'm on a carpet here, but if this was a solid shiny floor, it would travel much further because there's less resistance, and you've got a whole science lesson in there as well, different surfaces and how that affects the speed. So not a lot to do here other than just experiment and try different things to get familiar with the impact of those settings. So let's skip on and let's go to the first lesson where we've got to put things in. And straight away, you'll notice that we've got some functions here. Well, we know quite a lot about functions now. We've done those in 2 or 3 of the previous lessons. So our goal is to aim Sphero so it goes in the direction you want. So in that first lesson, when we just ask Sphero to roll, it does kind of shoot off in kind of seemingly random directions. But we need to aim it, which we'll look at in a moment. But we've got a function there that's called roll away. This is already written for us. So we're rolling away. It's going away from me if I'm having the robot in front of me rolling away. And we've got there that's a heading of 0. Now this is degrees. So this is 0 degrees from the way we're looking. So it's moving away, directly away from me at 0 degrees, a speed of 50. It's moving for 3 seconds, and then it's going to stop. We're now being asked to complete the second function, which is roll back. So we want it to roll away for 3 seconds, and then we want it to turn around and come straight back to us. So we need to start putting our first few lines of code in. So let's go straight into this, and we can look at the roll away function because it's going to be very, very similar. So let's put our first line in here. So we've got a roll, let's put it in, and we've got a heading, and we've got a speed integer, a number to put in here. So thinking about our maths, 0 degrees if it's going away, and we want it to turn around and come back exactly the opposite direction, we need to turn it around. So we're going to need a number of 180 in there. 180 degrees should turn it straight around and come back. Let's put the same speed integer. So we'll put 50 in there. And then if we need to check, we can always go back and have a look at our roll away function. We've got a wait command. That will tell us how far it's going, how long it's going for. So let's tap wait. And it's asking for a double integer. So we just need to get this syntax right. So we had 3.0 seconds. We do need to put that decimal place in there. If we just put 3, it won't work. It will get a syntax error there. And let's have one more line. Let's put the brakes on and let's press stop roll. So that's looking pretty good. We've got our function put together. It's very similar to the roll away, but this time it will turn around and come back. And then below that, we've got our code already written for us, which is simply roll away, wait for 2 seconds so we stop that momentum, and it rolls back. So let me go and grab my Sphero. Now, this time, when I press run my code, it's going to ask me to aim it. And it puts a shiny blue light on one side of the Sphero. So it's telling me now I've got to aim that blue light at my feet. So I'm going to stand it down here, aim it at my feet, and let me move the camera so you can hopefully see where I'm there. Can we see that? Let's move the stool out of the way. There we go. So let's run the code. We'll move the rug away because he doesn't roll on the rug very well at all. There we go. Turn around and on his way back. There we are.
Excellent.
So the Sphero there has completed that first simple task. So let's move on. So we've got the basics of this. So if we're thinking we are going to be building up this Pong layout, we've got him to move. We know how to make him move forward and come back. So we've got an option now. Let's do something a bit more complicated. Let's make Sphero move in a square. And it gives us lots of help here in the instructions. So it's telling us, we've just seen it, to move Sphero straight forward away from us is a heading of 0 degrees. We know that if we want it to come straight back towards us, so backwards here, that's 180 degrees. So we have got a left and a right. Right will be 90 degrees, left will be 270. So we are just using the kind of fairly simple mathematics there to get these angles right. And we've got to just put our code in to do it. And we're creating our function for roll shape. Now, you'll find with code, and we've said this before, that there is not always one solution. And there's two key ways of solving this one. And you'll find some children will do one, most of them will do the first one that we'll do in a moment, but there might be some who go a little bit deeper into it to try something new. So let's go into our function and let's put our beginnings together. So we want to set a roll. And if we want it to go, let's look at our notes here. If we want it to go across, like the way the arrow is suggesting on that little diagram, we want it to move to the right. So we know here that's going to be 90 degrees. So let's put our integer of 90, and we'll keep the speed at 50. We'll wait, and this will determine the size of the scale. So this is how far it will travel over this time. So let's wait for, we'll make it fairly small one. I'll put 2 seconds in here. So we'll do 2 seconds. And then we want to stop the roll, and just to make sure we can put another weight in there, just so that if we carry straight on, we might get sort of slightly rounded corners on our square. So I'll put another weight in there, and I'll just do a short one. I'll do 0.5 seconds. It just gives it that little bit of pause before it sets off again to give the corners a bit more squareness. So that will roll us across that bottom horizontal of that square. So we probably want to think about going, if we're going to go up, if we're going to follow those arrows, let's put another line in here, and let's roll. And we know, let's look at our notes, going forward is 0 degrees, look. So let's put our integer in of 0.
With those headings, I think of points of the compass. So 0 degrees is true north, straight forwards. 180 degrees is south. That's the way I remember anyway.
Yeah, there's a few ways of thinking about it, but yeah, it is. I mean, we're doing it with a square, so you could be doing this on angles and doing triangles and all sorts of things. So we've got our different settings there to go up the square. So let's put the other lines in. So let's wait for 2.0 seconds. Let's put a stop the roll, and let's put another wait. So we put those brakes on again. Let's go across the top. So we want him to go to the left, so that will be 270 degrees. So let's roll 270, 50. Let's put a wait for 2 seconds. So there is quite a lot of repetition for this. Stop roll and another wait for 0.5. And we've got our final one to put in where it comes back to our starting point. So we've had our 90 degrees. We've had our 0, we've had our 270, so we just need the one that comes back, which we've already seen in the last one, which is 180. So put 180, speed of 50, wait for 2.0 seconds, stop roll, and we'll have another wait for 0.5. So we've got quite a lot of code in here in this function to do the 4 sides of the square, and we've already seen there is quite a lot of repetition, but let's try it and let's see. So let's run my code. Let's line him up, and we'll tip the camera so we can see where he's going. There we go. We've got our square there. Now, that's probably the option most children will take when they're completing this one. But there's another option here we could do. I'm just going to tap the 3 dots. I'm going to reset that page, and let's just have another go at it. And we're in our function, and we've said there's a lot of repetition, and a square, in this case, obviously has 4 sides. So we are doing the same kind of thing 4 times. And there's a bit of a hint here at the bottom. We know a predictive code. We've got a for loop option at the beginning. So we could loop this, but we need to introduce something new if we're going to do it. So we're going to loop it. We'll put a for loop in. We've got that I for that iteration. So we want 1 in 4 because we've got 4 sides. And then let's loop this code. So we'll write it once. We'll loop it 4 times. Let's put our role and our heading in. Now this time, if we're only writing it once though, we don't have the option to write those 4 different directions in with that integer. So I need to put something different. And let's put an I. It's given us an I there for the iteration in our predictive. So I'm going to put a star, and we're going to put our integer of 90. So all we've done there, we've introduced a new command here. This is a multiplication operator. So all we're saying now is each time we've done this, each time we do it, we add another 90 degrees on. So we've put that command in there. So we only have to write it once by introducing that new option. So let's put in a speed of 50, and then everything else will be pretty much the same. So let's roll there. Then we're going to wait for 2.0 seconds. Let's stop the roll, and then we'll have another wait at the end of each corner, 0.5, so we get the squares there. So this shortened version of the code with that loop and that multiplication operator will achieve pretty much exactly the same. So let's try it. Let's get ready to run my code. So we'll put it over here this time. Let's have a look and see where he is on the floor. And let's run that code. So there we go, we've got another square. So another way of achieving the same kind of outcome, just in a much more kind of condensed code there, a much more economical code. So let's carry on.
We've drawn a square by drawing it in the Sphero app. We've drawn a square by coding it in by dragging and dropping commands in the Sphero app. Then we've coded a square using Swift, and now we've used Swift with a really optimized version. That's incredible. 4 different ways to draw a square, and each one getting more complex with the skills required. Fantastic.
Yeah, and in that last one, we've used functions and loops, and we've started using multiplication operators as well.
Yeah.
So we're getting quite advanced with this.
We are, yeah.
So we can control the Sphero. We can make him go kind of where we want now. So the next thing is we want to add some collision data in here. So when we're playing Pong, the ball hits the paddle. So that's a collision. We want it to recognize that it's hit something so we can make it achieve, to do something else, make it achieve something else. So we're going to add something simple in here. We've got an on-collision command introduced. And we've got some code here. We've got an on-collision, and it's telling us we've also got one here for setting the color of the LED on the Sphero. So we've got some code put in here, and there's something new again already. We've got 2 slashes and then kind of some text, some instructions there. And you'll find with a lot of coding languages, we have this 2 slashes, which then tells the computer running the program, just ignore this line. This is just a kind of a cut line that we don't involve as part of the coding. This is more for us. So I could write some notes in here for the children to see when they were looking at the code, just to give them some hints. And that's exactly what we've got here. So we've got 2 options in here, and these are what we call let commands. So we've got defining a red color using the UI color, the user interface color, with fixed color. So this is saying let red color. So if I just type red color, it's calling the UI color .red, which is fine. So it's just bringing that one up, it's making it red. We have another option. If we want something that's away from the primary colors, we could use the initialization function and using this alternate red color command here. And this just gives us a bit more detail. If you've ever done anything with kind of graphic design or kind of painting programs, we talk about colors a lot with RGB values, a red, green, or blue value, and the different percentage of red, blue, and green will give us the full spectrum of different colors. So if we use this option, we could specify different amounts of each of the red, green, or blue to pretty much come up with any color we liked here if we wanted to move away from that. So we've got a lot more control over that. We've also got an alpha control there. And if you saw any of the Everyone Can Create lessons we did, you'll come across alpha before when we were in Keynote, and we used instant alpha, and we used it to remove the backgrounds. It made the backgrounds transparent. Well, the alpha value of a color is to do with the transparency or the opaqueness of a color, or in our case, the brightness. So we can adjust the lights in a bit more detail. So those two let commands are already written in for us up at the top. So we've just got a function that we need to complete, and the function says on collision, we want it to do something. So on our collision, we want it to turn the light on. We want it to go red. So let's tap into our function, and we're going to set the main LED, and I'm going for that standard one there because it gives us it there, like the color, the UI color, and I'm going to go for red. And that's just a text there from that command up at the beginning, that let command. So again, let's run our code, and hopefully it's going to hit the rolled up rug at the corner and recognize that, and it will turn red. So let's place him back here. Let's tip our camera so we can see him again. Let's have a look. There it is. Balance the computer on there. Let's run the code. And off we go. And it shoots off there. And you've just seen him on the edge of the screen.
I saw it go red. Yep.
It's gone red. So just to grab him. There he is. A nice kind of shiny red one. So he went red when he hit it. So let's move on. Let's go to the next chapter. Now, this bit's a little bit disheartening. We've got another introduction in the middle just to kind of educate the children on what Pong actually is, which kind of makes me feel far too old that we have to start telling children what Pong is. But there it is. We've got the little paddles on the screen, and we're going to recreate that in real life. But instead of using paddles and be on the screen, we're going to get the children up, and they're going to be using their feet as the paddles. And instead of having a ball, that's the Sphero bouncing between them. So it's kind of like a real life dancing around Pong kind of version of the classic arcade game. So we need to build our pitch. So we need to get some sticky tape out, we need to measure it, and we need to put the markers down for the pitch. We want to build the mechanics, and we're going to determine a winner. So we might not get through all of this today, but let's have a quick blast on the next couple of steps in doing this. So we've got our basic layout of Pong, and we don't have to do anything on here. We can change the colors, we can change some of the parameters. Let's make the ball yellow. Let's change the paddle colors. So this is really just to let the children get a bit more familiar with the game. So we can run the code, and then I can grab one of the paddles on the screen to play against the iPad. So let's just run the code, and I'm going to grab this one. I'll be red. There we go. Oh, the iPad's not very good at this today. Oh, always missed it again. But we can have a quick go at playing the game, just to kind of get the idea of what we're actually trying to achieve here. So, real world setup, we need to define the size of the pitch. How big is the Pong pitch going to be? So we need to lay out some tape. And it's suggesting here in the kind of the guidance that we need to make the pitch somewhere between about 150 and 250 centimeters. So it already gives us that let command at the beginning, and it's let the distance apart be 150. We can change this if we want, but this is just trial and error now for the children to say, if you are going to set the distance of 150, how far is that for the Sphero to roll? And we just need to put in our basic roll. Let's leave it on a heading of 0, so it's going straight forward. We'll put a speed of 50 for the now. And let's wait for, let's put 5 seconds in, and then we'll put the brakes on. So stop roll. And this is just really trial and error now to say, actually, on the surface you've got, how far and how fast, how long does that time value need to be for Sphero to roll a distance of 150 centimeters? And depending on the surface, depending on what we're doing, you might find that sometimes we need to have a speed of 100, sometimes we need 50, sometimes we need to wait for 6 seconds instead of 5. It just lets the children experiment and try and improve that accuracy of what we're going there. That's a really simple one, really. We just put in everything together that we know, but within that context of how far are we going to travel. So let's move on. And this is where it starts getting interesting. We've got what looks like a fairly complicated diagram. And this is just showing me that if I'm stood at the bottom of the screen and I've got player 2 up at the top of the screen, I've rolled the Sphero over to them and it's hit their paddle, their foot in this case. We need it to bounce back and come back to me. Well, we know how to make it recognize a collision. We've just done that where it changed color. We know how to make it come back. But it's not a very interesting game if it just bounces from one to the other. What we need to do now is make it bounce off at a random angle. So it adds that element of risk and that kind of excitement to it when we don't know which way the Sphero is going to bounce. We know to bounce back to me, to come back to me, is going to be a direction of 180 degrees. It's coming straight back to me. But that can be our base angle we start from, and there we want to add in some kind of random element to it. So it could be either side of that base line. So we've got a couple more commands in here. We've introduced the volley command, and we've got our base angle in there. So let's finish this function and let's see what happens. So let's put our roll, and we roll with a heading. If I put 180 in there, it will come straight back to me, but we want to randomize this. So in that integer there, instead of pressing 180, I'm going to put this random number element. And this lets me have a minimum and a maximum integer. So let's put a minimum of, let's go for minus 30, and let's put a maximum of plus 30. So just 30 in there. And let's put a speed of 50 for the moment. Okay, and then we need to do the same that we normally do, and let's set the speed at 50, and we could carry on and put the weight, the distance, and all the other things in there. So let's try it. Let's see whether that's going to work for us. So we've set that in our function there. Let's see what happens. So I'm going to run it forward. It's going to hit the edge there, and then hopefully it's going to bounce back at a different angle. And we'll do it 2 or 3 different times to check it goes in different directions. So run my code. Let's tip the screen down again so we can see the rug. And let's run the code. Oh, what have I done there? I've got a syntax error pop up. Let's have a look and see what's up with my code there. So this is a good one when the children don't quite get everything in there. So what have I missed? So integer, roll, heading, random number. Oh, I've not put my base number in there. So let me restart this. Let me reset this page, and let's put this one in again. So let's put our code in. So we want to roll, heading, and we want to put our base angle first. So we know that direction. So we need to establish that base angle plus the random number. That's what we missed out that time. So let's put that minus 30 in this time, and a maximum of plus 30, and put our speed. So the problem we had that time was that we'd set our random interval, but I hadn't set where it was random from. So I hadn't told it to start at that base angle, which is that straight line back to us at 180. So you'll notice there, it's quite nice because it does ping up with that little red dot to tell us that something's not quite right with our syntax. It's not going to work. Let's try it. So let's run our code. There we go. I've got my blue light on my Sphero. So let's place that down there. Let's tilt the camera. And let's run the code. And you'll see it on the screen as well with that overview. So there we go. Oh, and it's bounced back almost direct, 186 degrees that time, so nearly straight back. Let's try it one more time. Let's run the code again.
Well, at least we know it's random.
So there we go again. Oh, 185.
185, wow, what are the odds of that?
Let's try it one more time, and let's hope for something a bit more
Let's
exciting.
go for 184.
Go on, just to kind of keep that consistency. Go on. Oh, slightly different there, 194 this time. So it is completely random, but it's within that parameter of kind of 60 degrees there. So let's move on. So we've kind of got this coming together now. So we've got our bounce angle, and we just need to keep it going backwards and forwards. So let's move on to the next page. So we know how to make it hit the paddle. We know how to make it come back. We just need to keep the game going. Otherwise, it's going to be a very, very short game. So we need to introduce some if and else commands here. So let's go into our function. So we've got a collision data. Let's put an if. And we need to introduce a new option here. So if the current player, let's bring up our keyboard. And we're going to put in 2 equals signs, equal, equals, and then we've got an option. This is what we call a comparison operator. So if we're going to have this, this is what it does for player 1, for player 2. We need to have a base starting point, like we did with the direction. So let's put a comparison operator in there. So we'll say if it's, we'll start with player 1. So that's our standard, that's our default. So let's go into our code. So if the current player, well, let's do current player equals, let's do number 2, because that's the one that we're sending it to at the moment. So if the current player is current player 2, let's volley, and we're going to use, for the moment, a base angle, and we're just going to turn it around straight back to us for the minute. We'll add that random element shortly, and then we can set the main LED, and let's make them red. Okay, let's tap on these brackets around the if-else command. So we've finished that bit now. We need to add that else statement, or else the current player is equal to player 2 this time. We'll have a volley base angle of 0, and we'll set the main color this time to .blue. There we go. So now when we run the code, it should change color as it dashes between the two. So let's try this one as well. And let's check that we're okay with this. So let's run my code. Let's line up Sphero and tip the camera one more time. And hopefully, when it hits the logo, it's changed color to red. Oh, it's shot off to the side. Gone back to blue. I don't know whether you're seeing that on the screen. Oh, it's hidden.
Yeah, we can see that. It's coming across well.
So we've changed color, and this is why it's good fun, because you spend time chasing him around. So it does change color as it does that. So we get in there. We're nearly there with our kind of Pong. Let's stop that. Let's move on. We're nearly there with our Pong setup now. So we're running out of time here, but we have got 2 more steps in this, but we've got the basics of our Pong game put together. We have got this option here now of adding score, so keeping score to it, and it gives us this other operator here. This is the locator Y. So we've set our distance. We've said in the code there, let distance apart be 150. That's the size of our pitch. So we're going to be stopping the ball rolling with our feet at that distance. If it goes beyond 150, the Sphero is working out that you've probably missed it and it's rolling on further than that, so then that player has scored a point because it's gone past them. So we've got lots of options to put in there to add the scoring. And the next one is, of course, if we're going to score, we need to set a winner. So otherwise, this is going to be a very long game. We're going to have Pong championships and they're going to go on for a long, long time. But we've set here, let a winning score of 3. We could say it's a winning score of 10, depending on what you want to do. So how many times does the player miss it? And we carry on before we get to the end of the game. And it just pings up. And we have 3 outcomes from this. So it says there, we've already got it in for return 0. That's if there's no score. So that's probably at the beginning of the game. But the other options will be return 1 and return 2. So player 1 or player 2 won. So we're just building that scoring mechanism into it in these last couple of stages. We don't need that to make it work. We've proved we've got everything to make it work, all those elements. And then the final stage is really just to play the game. And this is already there for you. So this is just taking all those stages that we've been through. We've got some elements that we can randomize here. We can change the size of the pitch and the speed, but the rest of the code is already there. And what's nice about this is we've got those 2 slashes in there. So there's lots of comments here. So we could set the children, just have a look at this, see if you can work out what's happening in the code and those things that we've been putting in and how we've been working with it. You could even start with this and let the children just try and pick out some of the things that they recognize before we go through those whole processes. But you're all set up there, ready to start Pong championships with a Sphero.
Absolutely fantastic. And yeah, I think we've seen what versatile resources these are, both playgrounds on the iPad and the Sphero itself. If I was being taught, I'd probably stop at that stage where you're actually playing with your finger on the screen and probably give that quite a few minutes before moving to the next stage. But you've got to teach people what Pong is, haven't you? Absolutely. Oh, incredible. So yeah, I'm glad you love the Sphero. I love the Sphero too. I've used the Sphero Edu app quite a lot. And yeah, the possibilities are endless. And now we can sort of apply this into Playgrounds with Swift as well. So what a versatile resource. Fabulous. So if you want to know more about Swift Playgrounds and everyone can code, then point your iPad, iPhone camera at that QR code. It will take you to Apple's webpage, which outlines and overviews the program. About halfway down that page, there is a big PDF you can download, which will start to map hours of activity at different age groups. So really useful there. You can integrate it into your main computing lesson, or maybe use it for an after-school code club as a little extra for those that want to take it to the next level. There are plenty more resources from Apple to support you in classrooms as well. And the best place to go find out about those is the Apple Teacher program. Apple Teacher is free online professional learning. You just log in with your Apple ID and work through the modules, and you will earn the accreditation Apple Teacher. The top QR code there is the overview of the program, and the lower QR code there is how you sign in. So sign in with your Apple ID, and away you go. Earn that badge, print it out, stick it on your staff room wall, your classroom wall, wherever, and demonstrate your knowledge to others. Now, finally, before we leave you, we'll just tell you about our MCC MyLearn Computing Toolkit. This is the very best of the best resources to help you take this computing and coding to the next level in your setting. We include 16 iPads, one between two for the class and one for teacher, in rugged cases and a charge trolley. You get 15 Spheros, so one between two for the children, and 5 of the Sphero Rover robots, so they will keep your children and yourselves happy and engaged for a long, long time. Lots to do. You're not going to run out of things to do with this toolkit, and lots of lesson activity content from Apple and Sphero to support you. So that's all available for £289 a month on a 3-year MyLearn subscription. If you'd like to know more, contact us at MCC, and we will happily come and bring these these great resources to your setting so you can take a look yourselves. With that, that's it for this series. Dave and I will confer over the coming months to decide what we might do in series 3. So watch out for that. Thanks for joining us. If you've enjoyed the videos, they're all on our MCC YouTube channel. Share them with your colleagues. And we do this because we enjoy it, don't we? And because there's some great resources that people just don't know about. So hopefully we've done that through this series and the last one before it. So we hope to see you again. Thanks for joining us. Goodbye from me.
Brilliant. Thank you, Richard.